So I don't know if you watched or if you checked out the last one. I'm not sure the sound worked on the last one. Did anyone look at it? But okay, you didn't need to, but I think the sound's working this time, so I think that'll be good. All right, so questions on last week. Any questions on last week? Like you did this one, correct?
Yeah.
Yeah. Have you done, you haven't done this one yet?
No.
Okay, so you're not gonna do the entire thing, just so you know. You are gonna do, it's called lab 2, and you're gonna do just the top 3 boxes. Okay, so again, it's a layout problem, kind of like we had before. But I believe it's in the metric system. So the 10 is 10 millimeters. And the 12 is 12.5 millimeters. And the 8 is just 8 equal spaces. Okay, so these top 3. So the layout is very similar, right? You still want to lay it out the same way. You just don't have to lay out the bottom 3. I mean, I guess you could do these if you really wanted to, but they're tricky, right? This time I don't care if you use a straight edge or not. You can use a straight edge if you want to. How are we going to get a metric measurement if we don't have a metric scale? Yeah, we just got to do a conversion. So I want to cover that real quick just to make sure everybody can convert from one direction to the other. So if we have 12.5 millimeters, the way we should be doing this is what's called unit conversion, and that's dealing with the units. Like, how do we get from millimeters to inches? We have to look up that conversion first of all. Anyone know that one by heart? I always remember 2.54 centimeters per inch. For some reason, that's the one that I remember, which means if it's 2.54 centimeters per inch, we can write that conversion in fractional form in either position. In other words, I can put the 1 inch on top and the centimeters below, or I can write it like I did right there. Either way. And the goal is to get those units to cross out. So there's 10 millimeters in a centimeter, right? So you just move the decimal point one place and you have 25.4 millimeters per 1 inch, right? Or it can be written 1 inch per 25.4 millimeters. So that's the kind of the trick with using the conversion, is you can put it in either position. And if we're going to multiply this number, and all numbers are over 1, so I always just write it over 1, put it in a fractional form, right? If I'm going to multiply this by a number and I want those millimeters to go away, then I want those units on the bottom of whatever I'm going to multiply by, right? So I'm going to multiply by this one because that gives me millimeters on the bottom, millimeters on top, they're going to cross. So I'm going to use 1 inch, 25.4 millimeters. And then the millimeters cross and I'm left with inches. So that's like the fractional, we call it just unit analysis, because we're taking a number to another number just by driving the units correctly. So now I need a little calculator. It looks like it's about half, right? Yeah. So 12.5, enter, 25.4 divide 0.49, right? 0.49 inches is 12.5. Pretty much a half inch if we're doing manual drawing. Good luck finding 0.49 on your scale, right? You're just not going to find that. You're lucky to hit the half mark, right? So for this exercise, that's what you got to do for every number. Fortunately, there's not a lot of numbers, but you know, to figure out what the 12.5 is, we needed to do that conversion. To figure out what 10 is, we need to do that conversion. Unless you get a metric scale. We're not going to do that much metric work. I don't think you need to buy a metric scale. I guess if you get out there and you're doing graphics and they have the metric system at your work site, then I'd get a metric scale because it's a hell of a lot easier than having to convert every time. But you won't need it for in here. Okay. Everyone good with that? All right. And you can use a straight edge. There are a number of different kinds of lines. I'll just cover this real quick. We're going to do a whole section on like, what do these lines mean? But this is our typical visible line, that continuous line. And that is supposed to be thick. Like this one appears to be, I don't know, maybe they're the same. Anyway, so we have thick and thin. That's all we have to worry about. Thick and thin. So some lines are thick, visible lines are thick, and those represent edges we can see. So when we're drawing something, an object, if we can see that edge from our view, then that is a visible line. Lines represent edges. So again, if I'm looking at this view, the top view, that's what the T is all about, top. It's so we all choose the same top. This right edge here, that's visible. So that's a thick line. But this, if I was looking at it from this way, right? All four of these edges are visible. I can see them. The circle is visible. So those would all be thick. But back here in the back, I can't see that edge and that edge. So that would be hidden. And this is a hidden line. And hidden lines are thin. And I don't care how thick your thick lines are or how thin your thin lines are. All I care is I can tell the difference. Like, oh, that's clearly thick. And that's clearly thin. That's all we need. So you can see that there's some other lines that they have as thin. They have this one thin. That might be a dimension line. They're thin. Visible line thick. This is a hidden line. This is called a center line. Center lines locate things like holes. So we would put a center line through that to locate it, right? Because what we're looking for in graphics is the full shape description. We want to define the shape for whoever's looking at this thing. All right. And then there's this line, which is called a phantom line. It's got 2 dashes. It is a cutting plane line. So when we do sections, we have to represent where we're cutting the object, because then we kind of peel it open and look at the guts. So that's for an object that has a lot of hidden geometry. We're going to do these sections or cuts. So that's a phantom line. And then this is a thin phantom line. Trying to think what I would use that for. I don't know. Because cutting plane lines are always super thick. Like this is the thickest line on the drawing.
Section line of surface you can't see.
Yeah. Section lines are just regular continuous lines. They're thin. But a thin phantom, I don't know. I'll have to see where they use that, even if they do use it. Center. That one. This one? This one. Hidden. Hidden edge. An edge that we can't see. So like on this object, I can't see this edge and this edge. I know it's there, but I can't see it. So it would be hidden here. So that would show up like dash, 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 dash on this view, right? Because there's these 2 surfaces.
The one next to it is a solid light line.
Center line, dimension line. So like if we're dimensioning something, so like that dimension right there, right? The 12.5, it's thin. So all dimensions are thin. I can probably just like flip to a page and see dimension lines. Oh, of course not. Oh, there we go. All right, whole bunch of dimension lines here. Yeah, so these are thin, all dimension, all leaders, everything calling out geometry thin. The only thing that's visible thick are the edges that you can see. And if there's something we can't see, then it's going to show up as a hidden line. Yep. So that's just basic line work there. And you can see some center lines here. Oh, there's a thin phantom. Yeah, I don't know why they did that. Oh, it's a double mark. So that's marking here. Could be just a general symmetry line, maybe. Everything's symmetrical about that, right? So that could be a symmetry line.
Does the center line have to have 2 dashes on it? Or can it
No,
just be-
single dash. Center lines are single. Yeah. So the 2 dash there, I think is a symmetry line, but here's a typical center line.
Sure.
And your marks line up. I mean, manually, we can do that really easy. We can give ourselves a pretty center mark. See it?
Yeah.
And then off it goes in both directions. Boom, it's just locating something. In this case, it's locating the center of the slot. Okay. Yeah, so lots of dimensioning is very complicated. Like there's a lot of rules to this and we'll get to it, but they break a lot of the rules in this. And they do that intentionally, so you don't just regurgitate the dimensions. Otherwise, you just copy what they did, right? So we have to learn all those rules. We're not dimensioning for a while. All right. We're good with that? Because I'm going to move on. All right. Great. Let's talk a little bit more about scales and scaling, just so we understand that. And I think I was working in my office last night and I left my really cool little triangle scale. But that's all right. We can use the book who shows a lot of. Does anyone have a triangle scale yet? Did you find them anywhere?
Office Depot.
You did get them at Office Depot?
Yeah.
Yeah.
Stedler has a pack that has.
Yes, they do.
2 of these and
Yep,
round and compasses.
yep. Oh, come on, where's the? Oh, here's the page 49 has the lines on it. Here, we'll see if we can find. So phantom line, they're calling this. It's thin, and they're using it for, like an angle location or a radial location. And then the cutting plane line can be big dashes or it can be phantom, either one, cutting plane line. But that's all on page 49 where they go through it, but you don't have to go through it yet. But if you're just curious, that's where it's at. All right, so scaling. These triangle scales will do it for us. And we're going to work with the engineer scale and the architect scale. We're going to do both. So remember, the architect scale is eighths, quarters, halves, sixteenths. That's what's on an architect scale. That's much different than an engineer scale, which is just 10 marks per inch, right? 1/10, 2/10, 3/10, 4/10. Okay, we will work with both of them. Both of those do the same thing. They reduce. Neither one of these increase. So we need to size things up now and then. You're going to work with these today and they're really small. So these we're going to have to size up. This thing won't do it. This will only reduce. Okay, triangle scales only reduce. What industries blow things up a lot? Like the aircraft industry is all about like reducing that thing to get it on the paper, right? What industry would make things much, much bigger? Any ideas? Microchips, exactly. So everything in Microsoft, any drawing you see at Microsoft might have a scale that looks really weird, like 100:1 instead of 1:100, right? So 1:100 is 100 times reduction. 100:1 is 100 times bigger, and you can still barely see that little microchip. Like they're so small, right? So we got to kind of get used to what the notation looks like, and then how to do it. A little more. I want some color. Black's not really color. Ooh, ooh. All right. So normal scale notation is something like this. You'll see 1:1. And that means, and we don't usually put a unit on it, but it means 1 inch equals 1 inch. In other words, oh, that's a 1:1 drawing. If you see 1:1 in the corner, usually it's in the lower left corner where the title block says scale. Somewhere down in here, scale. Barely see that. Right, so there's title blocks in the front cover. We'll talk about that. But all drawings should have a scale on there. And NTS is an appropriate scale. What's that mean? Not to scale, right? You'll see that at times, like, oh, that usually means that they produced a drawing, but the drawing's super big, and then they just use the copier to reduce it down and get it on a normal piece of paper. And then somebody just takes a red pen and writes NTS. Like, this is not to scale, but here you go. Good luck, right? So we really should not be scaling drawings anyway. So it shouldn't matter. We're just going to read the numbers on the drawing. So if you're working with a drawing, you're going to use the numbers on the drawing. You're not going to take a scale and flop it down and try and figure out something. If something's missing, you go to the source and say, you got a missing number, we need that number. So, all right. So then if we go like this, using our new logic, that's going to mean 1 inch equals 2 inches. So this is real 1 inch, right? So the first number is always a real world. It's a real 1 inch, but it's going to equal 2 inches. So when you draw, if you had a 1:2 scale, it would be half as big, right? You can also think of like, oh, this is a little like fractions, half scale. Okay. And then 1:3, same kind of thing, 1:4. This is a 4 times reduction. Okay. And the advantage to these is once you decide the scale you want, flip it down and use it. You just read it directly and it's reducing it. And you'll feel that once you get away from like 1:2, like a 1:4 is like so small, 1 inch is like that. It's like this big 1 inch. It's really, really small. So you'll feel that reduction when you draw with it, but it's just nice because then you can just still literally read the scale as it is. So that's reducing. If we're going bigger, then the scale flips like 2:1, right? So then 2 inches equals 1 inch. 2 real world equals 1 inch. All right. So, I mean, you can think of it as a multiplier. If I'm going to draw this creature and I measure it and it literally measures, I'm going to say it measures 0.8 inches. Right? That's what I measure it. But if I want to get it bigger on the drawing, then I can go times 2 and I can get 1.6 inches. And now this becomes that. And when I lay my ruler down, I have to measure 1.6. So it's more work for me to blow it up. I have to remember to do that every time. And if I forget, then some dimension's all wonky, right? So making things bigger is a little more time consuming for us. Definitely need a calculator to do that. Don't do it in your head. Even the basic numbers, don't do it in your head. Just use your calculator, crunch it out. Okay. Same kind of thing. If I wanted a 10:1, so that's a big increase. 10 times bigger than it actually is. 10 times bigger than this is going to be like, 10 inches. This is close to 1 inch. But I just multiply times 10 or just move the decimal point. It's super easy. So you'll find a lot of 10 scales because that's easy to do. The reason we scale is, and this is important, is we want to fill this paper comfortably. So on the paper, I don't want my drawing to be like top, front, and side view on this piece of paper. Like that's, then I have to dimension like this. And pretty soon it's just a mess, of trying to dimensions get smaller and smaller, and pretty soon nothing fits. Okay. At the same time, I don't want top view, front view, and side view. I don't want it that big because now I'm running out of spaces to put my leaders and my name of my view. Right? Pretty soon it's just all congested and it's too big. So both can happen, too big, too small. And you just got to pick the lesser evil. The lesser evil is too small because then you can still get your dimensions on. If you pick too big, then you really go down a rabbit hole. So there's a lot of forward thinking goes on with manual drawing. AutoCAD, not so much. You just start drawing. You don't have to think about scale. Everything's 1:1. And if it's too big, you scale it later. If it's too small, you blow it up. I mean, it's a different game. So this will get you thinking about like how much space you need for dimensions, you know, in here and in here, like how complicated of an object is this? A complicated object is going to take a lot of dimensions. A simple object like this, we're going to need, you know, this dimension, that dimension. At some point, we're going to need the height and the location of this and this. That's about it. I mean, the slot. That's it. All right. Good. A few different ways to measure, because we're going to do a lot of what's called as-builts, because you will do a lot of as-builts. We like to think we're very forward thinking in engineering and manufacturing, but we're not. We tend to manufacture shit and then document it later. Like they built it and now they want drawings on it because it seems to be working. It's like, really, guys? So then you end up crawling around it, measuring everything, right? So that's called an as-built. The drawing is capturing how it is built, right? If I have you draw this, that's an as-built. It's already made. Like you're not designing it, you're just documenting what it is. So we'll do a lot of as-builts. It's easier for us, but then we'll do some original. You'll get to do some design work and create your own objects. Okay. So how do we measure something that's existing? There's a lot of different tools out there for that. We don't have most of those tools. We have some of them. So the one we're going to use a lot is a caliper. I have several of these, so we'll use them a lot. This is a pretty precise measuring tool. This, much less precise, right? But we also have these for bigger objects, because this is only going to go up to 6 inches. Anything bigger than that, it's not going to measure it, right? So then we would go to something like this, and we'd actually just do our best to measure it. All right. If you've not seen one of these before, I'm going to show you how it works. And then I have a lot of them, so you all get to practice with them today, okay? It measures in engineering scale. So it's not going to give you 1/8 of an inch or 1/4 of an inch. It's going to give you tenths. What's the next one? Hundredths and thousands. Yep, that's what it's going to give us. So in number form, that's 1.767, right? This is whole inches. This is tenths. This is hundredths. This is thousands. Perfect. This goes to thousands, as long as you can read the little dial. You have decent eyes. Okay, so there's a little roller here. Roll it around. You want to close it all the way and make sure it zeros. If it doesn't zero, then you just take this little outer case, kind of loosen this little thing. It's nice and tight. That's good. And you can actually spin it. So you put it right on 0. These stay pretty zeroed unless somebody really reefs on it. It does pretty good. Zeroed up. So that's closed. And then as you roll it, that dial just goes crazy, right? So we read this scale. Sorry if you've done this before, but that's all right. It's a good refresher. We read the scale along here. That's our inches and our tenths of an inch. So it's pretty hard to see, but that is a 1 and that's a big one. So that's 1 inch. Okay. So if we're past that 1, then we are 1 point something, right? If we're past the 2, then we are 2 point something. Make sense? If you're really close to it, like that, we're close to the 2. I see the 2, but are we to the 2 yet? No, we're not, because the dial is where? It's not to the 0 yet. If the dial got to the 0, then that would be straight up to 0.000, because it's going out to thousands. Okay, so we read this one first. So right there, it's going to be what? 1.5. And do I see the 6? Nope. So this is 1.5. Then you read the dial. So you get, huh?
Sorry, cameras are high up to read out the paper.
Oh, perfect. Oh, I'm really zoomed in, aren't I? That's awesome. All right, maybe that's a little too much zoom because I want the dial too. Ah, there we go. Good. All right, 1.5, and then we just read the dial. They're super easy to work. And the battery doesn't go dead. If you got a digital one, those are super cool, but batteries always go dead on me. So then what's our number? Yeah, so here's where like 4.2 is right there, 4.3 is right there. It looks closer to the 3 to me. So 4.3. If you were on to be on the safe side, you might use the smaller number, 4.2. Some people think they can read that like, oh, that's 4.28. I'm like, I don't think so. You're not getting 10 thousandths out of this tool, right? So that's it. That's how you do it. All right, read another one for me. You're going to write it down though. So don't say it yet. Well, I'll get a chance to read it. Y'all can see it. All right, what's our inch number? 3. And then what's our tenths? 6. 6. And then what do you read on the dial? Oh, it's right in the reflection.
Yeah, it's in the glare, but I'm pretty sure it's the same.
Is it that bigger one's 5? Yeah. All right, good. You can get these out, zero them up, make sure they function. And when we do projects, you're free to take these home if you want, just let me know and we'll kind of check it out type of thing. Because you're gonna be doing some measuring of stuff and drawing of stuff around your house. So close it all the way. And then it's the dial, it's the spin dial at the bottom, this one that you loosen. Just a little, just loosen it a little. And then the outer case should spin, this case. The top one is the roller lock. This one, so that should be free. It'll stay in position. I mean, I guess if you're gonna take a measurement and then bring it all the way to school, you would lock it, but I don't typically lock it. Everyone getting it to 0? All right. So some of these have a little rapid prototyping stuff left on the bottom. Just ignore that. You're not drawing that. If you're not drawing the T, like because it's not on the bottom. I just thought it was else stuff really stuff that wow. All right. Well, let's just do some measuring and see if we're getting close to the same numbers. Let's put it in a position that we're all, So put it in the position where you're looking at the top that has the T on it. And then the T is in the correct shape, like a normal T, right? And then let's measure the X and the Y dimension, basically. So across here, it's a rectangle. So let's measure across here and across here. I'll have one more of them. I don't get to play. Should just take a picture of it. All right, what do you get for that X dimension across the bottom? So almost flat at almost an inch, right? So 3 inches is right there. Right? So I'm thinking that's a decent size to go on this piece of paper. Because I'm going to be here. It's about the same as it is. I think this one will fit and this one will fit. It's close. It might be a little big, but I'm going to go with a 3-to-1 scale, right? So I'm going to kind of start to draw this. And our drawing layout is top view. And since we've defined the top view, then the front view will be here below the top view. And then the right side view will be here, front, top, side. Very standard, what we call orthographic layout. Ortho meaning 90 degrees. Each view is 90 degrees from each other. Okay, so top view, front view, side view. Very typical. They're called the primary views. We use them all the time. Engineering disciplines, mechanical, civil, electrical, would all use front, top, side. The construction world or architecture world would use plan view. That's the top, looking down at the structure is the plan view. And then east elevation, west elevation would be just these different elevations or side views, right? So different terminology, exact same concept. Plan view is the top view. Some directional elevation is the front view. Another directional elevation is a side view. Okay, so we'll flip back and forth between that terminology. All right, so I'm going to go with 3 because manual drawing, that's about as accurate as I can get anyway, right? So, but I did put little marks in there. And then how tall is it? 1 point what? Same thing, right? Approximately. So now I'm using my triangle just to get kind of 90 degrees. So this is sketching because I am doing it by eye, right? But I am using a straight edge, but I'm still sketching. That one's harder to get, so I'll flip it over. Just using that inside part to kind of keep it at 90 degrees. We don't need to get too anal about it, but it's nice to be kind of right, you know? Yeah, this is pretty big on the paper, but I'm erring on that side of pretty big. And again, I might use my triangle scale instead of this caliper. You know, I could be laying this on here, doing the same thing. I'm really working on right here, just getting you educated on drawing layout and these views, because we're going to spend a lot of time with orthographic. I'm doing it really light. I'm not trying to darken anything. Typically, you just do it super light. Like it could even be lighter than this, because if I had to erase, which I want to erase these little tails and stuff, you know, I'm not going to get it all. That's so dark that I would have to like really grind. And if I want to be really detailed, then I want to try and clean all that up. So just do it really light. So then, just to show you drawing layout, you're going to want a title. And again, you're not going to want the title too close to your drawing because dimensions would typically go in there. We're not mentioning, but at some point we will be, right? So then I give myself some guidelines and I should measure that. And, you know, whether that's an 1/8 or a 3/8 or a quarter or whatever you want to make it, or whatever I ask you to make it, that's what it would be. But then I'm going to use my lettering skills. Right? And I'm going to go top view. Name of the view, always under the view. So don't be sticking it off to the side because you didn't plan. Right? It's got to go under. I will hit you for that, because when we end up with 6 views on here, we need to be able to find the name of the view quick. Like section AA, where is that? It's there. I don't want to have to look over there for the drawing, right? Should be right above the title. So that's that one. Now you would rotate it. So if you're looking at the top, you would rotate it away from you, and then that becomes the front. Right? Well, we don't have to measure this dimension because we already have that. So this is called projection. We want our views in projection. So the front view, these two edges, since this is just going to rotate, right? Those edges are there. In line with this one, that's called projection. Now, I need a new height. I don't have that yet, right? So measure that for me. Rotate this thing and then measure the height. And I know I'm not done with the top view, right? There's other lines in there. But I'm going to draw the bottom on because I'm going to put the bottom where I want it. Then I'm going to wait for you to get the height of the thing.
You want to put the stuff in the bottom?
No. That stuff's not supposed to be there. Don't include the junk on the bottom, if there is junk on the bottom. Oh, I went up to the new coffee food place and I got a mocha. Just, supporting them because I want them to stay open.
How is it?
It's delightful. It's like the old days where you could walk around a campus and get like a muffin and a coffee,
Where's
And
it?
I don't know if you've been it's by the library. I don't know if you know where the Black Rock used to be. It's in there. It's in the library, but it has a window, so you don't have to go into the library. You can just order from outside. But right now there's like a whole fair thing going on in the common area, like a giant fair thing. Next Adventures in there. I saw that. They had like snowshoes. Snowshoes a thing?
Snowshoes.
Like of all the things you bring as snowshoes, I'm like, isn't that just walking in the snow? No, it's different than walking in the snow. Okay. I need to stop talking about snowshoes right now. I love it. I see them now and then because my wife's cross-country skier, so I do that. She forces me to do that at times. And I see them sometimes walking like at Tilly Jane, but they're walking in the groom with snowshoes. I'm like, aren't you supposed to be like out in the snow with snowshoes? Right? So you don't sink in, right? Like, go out there in the trees, go walk across the lake. I'm kidding. What's the number? What's the height? 0.756. And what's our scale? 3:1. So I write it on there so I don't forget. Right? I just put it on somewhere. So I'm like, oh God, I got to multiply every time times 3. So multiply by 3 for me. And what do you get? One and a half, 2 1/4, 2.
Basically,
2.2. Oh, this is kind of fun. This shows how many mochas I've had. I can't get 2.6. Yeah, I'm not going for the 8. I'm just going with that right there. Because my pencil lead is like, 0.16 wide. So I can only be that accurate anyway. Notice I am marking both sides because I don't have this, on a straight edge system. All right, I think you get it, right? You get the point and how this gets laid out. So I put this view a little too low because now I'm going to struggle to get the name of the view down here. So I'd probably stop, do some erasing and scoot this up just a little. Okay. Now there's other geometry that goes in the top, correct? Is it like this? I don't have the object. Is that right?
Yeah.
And then there's yep. So I did find my little box of tools. I used to have a giant box of tools, but I think I said that's ridiculous. But it does have a circle template of various sizes. This is the one I keep in my pack. Just because it's a nice straight edge, first of all, and it has little circles. And I don't usually need giant circles, but this is in here if you want to borrow it ever. There's 10 million templates, not that I have, but all kinds of templates to draw goofy stuff. When you go get your triangle scales, don't go crazy in the template area and buy 100 templates. I've had students do that. Like, look at this template I found. I'm like, cool. You're never going to use that. We're not doing it that much. But the circle one's pretty nice. Like, you know, you can position it, so you gotta measure over position. A lot of times you're just gonna need a cross to line these lines up, right? So if this was my box, I'd probably go like this and like this to find the center, if it's supposed to be centered, which I think it probably is, right? And then I'd try and do a horizontal line, you know, using my triangle and keeping these parallel. I can get pretty close to horizontal. And same kind of thing here. I can get pretty close to horizontal. And then once you have that, then your circle, you just line up those ticks and it works pretty well. Like all four, right? And then again, nice and light until you know, whoa, until you know what you want. That's the mocha. Yeah. They need to sell another drink that counters the caffeine. Like the downer drink to get with your mocha. That is sad. I agree. I really agree with that. All right, questions. So we have a little drawing layout and you have a little bit of orthographic projection to do. Yes, go for it. So you can go either way. So yeah, in the front cover of the book, it talks about paper sizes and it shows everything in landscape. Like here's landscape size A, that's 8.5 by 11. Here's a landscape 11 by 17. And then it goes bigger, 17 by 22. This is C size. And then there is a D size, and that's going to be even bigger. None of these show that. But they also show these little title blocks, right? So this little title block, actually the form 1 goes on the side of the paper, which would be a portrait drawing, if you want to go the other direction. So it depends on your object. Whatever fits is the way you want to go with it, unless it's in a drawing pack. If it's in a drawing pack and the rest are landscape, then you need to stay landscape because we don't want a goofy portrait one in with the landscape stuff, right? So it depends on if it's in a drawing pack or not. Most of the time it's landscape. Good question. And then obviously the right side would be in projection. Notice there's no projection lines, right? Like those lines are not there, but those do line up. Right, and then the right side would also line up, like it's going to be over here somewhere. Eyeballing this, right? And then it's going to be right side over here, but in projection, all three are in projection. All right, you do not have to dimension it, but you got to finish this up with your little object and your calipers, okay? Questions? Yeah. Oh yeah, we should talk about the rest of it. Yeah, there's other cool things. Thank you. Yeah, so the top is for measuring insides of circles or holes, right? So if I had this cup and I wanted to measure the inside, I just run it out. Yours is a much smaller one than me, right? But then you can just like reach in and measure the inside of something like a hole. Yeah, cool. And then this is depth. Yeah, so if you zero it, that should be right there. So then you can stick it on something, drive it down and get the depth of something. So that's super handy too. If something doesn't go all the way through and you need to know how deep that hole is or whatever it is, or some geometry, or even the shelf, right? That cutout on your object, you could use this, set it on the high part, and then run it down, you know, and measure the low part. So yeah, thank you for that. They're super handy. I have one in my shop and in my car, and then I have some here. So with that, you don't have to geek out yet on that, but they are super handy. And you look all engineerish when you pull it out. People are like, oh, he's going to measure something. Precisely. Yeah, and then I step something off to get a measurement, you know. Oh, 3 feet per step. I can do that. That's not so, yeah, exactly. Yeah. I'm pretty good with my steps, though. I've gotten good. I can do a 3-foot step. All right, I think that's good for today. I'll let you just work. I'll stop the recording.